Find maxima in BITONIC array. This is a new type of array. So basically BITONIC goes up then down, or we can define it as a BITONIC array comprises of an increasing sequence of integers immediately followed by a decreasing sequence of integers. So it goes up, then goes down. It increases, then decreases, just like a triangle, just like going up and down. Yeah. Since the elements are sorted in some order, we should go for an algorithm similar to binary search. Steps as follows. So to find the maximum value in a BITONIC array, we go through these steps. Take two variables for sorting start and end index. For example, the variable start 0 and the end size -1. Find the middle element of an array. See if the middle element is the maxima. If yes, return the middle element. Alternatively, if the middle element in the increasing part, then we should look for a mid +1. Alternatively, mid -1. This is the index, all right? Then we either go right or go left. We look for it. If it's here, then we go here. If it's here, then we go there. Repeat the steps until we get the maxima, all right? And here's the implementation. Search. This is wrong spelling. It should be BITONIC, okay? Array max, yeah, just like that. And again, we have here search elements. So search an element, any element, in BITONIC array. Now we will search for an element. BITONIC array comprises of increasing sequence of integers immediately followed by decreasing sequence of integers. We just defined that in the previous paragraph, so I read it fast. To search an element in BITONIC array, do these three steps. Find the index or the maximum elements in array by finding the end of the increasing part using modified search binary. Once we have the maximum, search for the given value in increasing part of the array using binary search. If the value is not found in the increasing part, search the same value in decreasing part of the array using. All right, so when we search in a half, then another half. There is a possibility that we find it, so the search took half the time. All right, and here's the implementation. And in this function or in this method, there was no typo, just like the second one. It says BITONIC. All right. So we need to find the max first, then searching. All right. And we are calling binary search function. And here is the called binary search function. All right. Occurrence counts in sorted array. So we are going to find how many times, or the counts of occurrences in what array? In a sorted array. So the first approach is the brute force that we do for loops and we count. All right. If it matches, then we count. Okay. Like we have just one value and we see how many times it's showing up in an array. So we do this. This is the very basic approach, the simplest way. The second approach, since we have a sorted array, this is the magical word, sorted. If it's sorted, then we can go with binary search. Binary search is way faster, right? Because it's sorted. First, we should find the first occurrence of the key, then we should find the last occurrence of the key, take the difference of these two values, and you will have the solution. Why? Because they are sorted. Because it's sorted, all right? So find the first index, then second index, and the difference is how many times it's showing, all right? Just like that. And because we are doing, and we are using arrays, so all the numbers, like the first is referred by 0 and the last is referred by the size -1. So to find the real number of counts, we just add 1 to correct that part. This applies for vectors, arrays, and similar types that start with 0 element, all right? 0 index. Here is the solution. Here's the find first. Here's the find last. And let's go to the next topic. Separate even and odd numbers in an array. Given an array of even and odd numbers, write program to separate even numbers from odd numbers. Just isolate them, just separate them, okay? First approach, locate a separate array. Then scan through the given array and fill even numbers from the start and odd numbers from the end. Second approach algorithm as follows. Initialize the two variable left and right. Variable left 0, right and equals size -1. So we are setting the beginning and the ending of the array. Keep increasing the left index until the element at that index is even. Keep decreasing the right index until the element is odd. Swap the numbers left and right. Repeat these steps. So at the end, we will have the odd at one side and the even at another side, and we separate them, right? By swapping. And separate even and odd numbers. Do the swapping. The next topic is stock purchase sell problem. We have a problem about purchasing and selling stocks in the stock market. And just like an example, given an array whose 9th element is the price of the stock on the 9th day, all right, you're asked to buy once and sell once. On what date you will be buying and at what date, on what date you will be buying and at what date you will be selling to get the maximum profit. Or, given an array of numbers, you need to maximize the difference between the two numbers, such as that you can subtract the number which appears before from the number that appears, this is from, okay, it's a typo, from the number that appears after it. So this part is just an explanation of how the programmer understands it. This paragraph here is a real life example. Who did this interpretation? Who read this and rewrote it like this? Some human or person or a job position called system analyst or application analyst or the analyst, all right? So he speaks both languages. He can understand this and he can understand this. He's just like an interpreter. He rephrased this one and made it look like this one. So the programmer, developer can really understand it. because the top one is kind of coded for developers. The lower part is very obvious and easy to understand. All right. First approach, the brute force. For each element in the array, find if there is some other element whose difference is the maximum. This is done by using two for loops. The first loop to select by date index and the second loop to find its ceiling data entry. The time complexity is a function of n squared and the space complexity is fixed. This is the very basic approach that all universities study. The second approach, always look for the other approaches. Another clever solution is to keep track of the smallest value seen so far from the start. At each point, you can find the difference and keep track of the maximum point. This is a linear solution, so it's a function of n, not n squared. No need for two loops, just one loop. You capture the minimum and you capture the maximum, then find the difference, right? So this approach is kind of clever. This approach is kind of very straightforward and easy to do. Which one we need to choose? We need to choose the one with the best time complexity and space complexity. Always. All right. Maximum profit. So just one loop and find the minimum and find the maximum. Max, current minimum. Right. And here we keep the maximum as a maximum. We calculate the current profit, right? The next topic is about finding a median of an array. The average in statistics, they call it median. All right, given an array of numbers of size n, if all the elements of the array are sorted, then find the element which lies in the index n. Sorry, I made a mistake. The median is not the average. The average, they call it mean, M-E-A-N. The median is the one that stands in the middle of an array. Like it's, if you sort the array, it's in the middle. They call it the median, all right? So the first approach, sort the array and return the elements in the middle. All right, the second approach is use quick select algorithm. This algorithm we will look into the next chapter. So yeah, it's not explained. In the quick sort algorithm, just skip the recursive call that we do not need. All right, so the average time will be fixed. So it's more efficient because the average time here is n log n, okay? And that's it. Two approaches only, finding a median of an array, median. The next topic is finding median of two sorted arrays. Now we have two arrays, two sorted arrays, but both are sorted, all right? First approach, keep track of the index of both arrays. Say the index are I and j. Keep increasing the index of the array, whichever have smaller value. Use a counter to keep track of the elements that we have already tracked or traced. All right, so this is just a linear. Find median. All right. Search 01 array. Search 01. Given an array, this is the next topic, search 01 array, okay? Given an array of zeros and ones, all zeros and ones, like binary digits. All the zeros come first before the ones. Write an algorithm to find the index of the first one. What's this? What's the number? What's the sequence? What's the index of the first one? Or you are given an array which contains either 0 or 1, and they are in sorted order, example ones and zeros. How will you count the number of ones and zeros? Like how many ones and how many zeros? The first approach is the binary search. Since the array is sorted, the binary search to find the index, the time complexity is log n. The logarithm of n. This is very quick because it's sorted. And here's the binary search. And it calls a function called binary search 01 and util. And here's the call function. And that's it. The next topic is search and sorted rotated array. Given a sorted array of s of an integer, s is rotated for unknown number of times. It's been rotated. Find the element in the array. Search and find an element. Search. It's rotated. It's sorted but rotated. All right. First approach, since the array is sorted, we can use modified binary search to find the element. And here's the solution. Binary search, rotated array. Binary search, rotated array, util. All right. Let's go from the beginning. Here's the solution, binary search of a rotated array. Then we'll scroll down, and here's the rest. All right. First repeated element in an array. Find the first. This is the next topic. First repeated element in the array. Given an unsorted array of an element, unsorted, find the first element which is repeated. Find the first element which is repeated. Find the repeated element, all right, in the array. The first approach is excessive search or brute force for each element of the array. Find if there is some other element in the same value. This is done by using two for loops. First loop to select the element, second loop to find its duplicate entry. All right, so this takes long time and square. And here's the solution. The second approach is by using a hash table. Using hash table, we can keep track of the number of times a particular element came in the array. First scan, just populate the hash, and the second scan just took the occurrence of the element in the hash table. If the occurrence is more for some element, then we have our solution and find the repeated element, first repeated element. All right, the first repeated element. Hash table insert and find takes constant time, so the total time complexity will be the function of the number of elements. Space complexity also like this for maintaining the hash. So it takes more space, but it's way quicker. All right, transform array. How would you swap the elements of an array like this? A1, A2, A3, B1, B2, B3, convert to A1, B1, A2, B2. This is called transform. So the approach is first swap the elements in the middle pair, next swap the elements in the middle two pairs, next swap the elements in the middle three pairs, iterate step 1 and 2. And here is the transform array. Next topic is find the second largest number in an array with minimum comparisons. And here we have three approaches, I guess. Yes, three approaches. Suppose you are given an unsorted array of n distinct elements. How will you identify the second largest element with the minimum number of comparisons? Like you want to find the second largest, but the quickest way to find it, okay? The first approach is find the largest element in an array, then replace the last element with the largest element, then search second largest element in remaining elements. So the first is to find the maximum, then isolated, then define maximum again. All right. Second approach, sort the array, then it will then give the n minus, like search in ascending order, then give the final one. This approach is still more inefficient because you have to sort first, and this takes a while. Third approach is priority queue heap. This approach will look into heap chapter. Use build heap function to build heap from the array. This is done in n comparisons. Array is the largest number, and like the first one, like it's descending order, and the greater among these, and the second largest. So ARR2 is the second largest. The next topic is about check if two arrays are permutation of each other's. Given two integer arrays, you have to check whether they are permutation of each other. First approach, sorting. Sort all elements for both arrays and compare each element of both arrays from the beginning to the end. There is no mismatch. If there is no mismatch, return true. Otherwise, return false. Sorting algorithm takes this time, and comparison takes this time. Time complexity of both. All right. Check permutation. The second approach, hash table. Assuming no duplicates, distinct elements, and I think it's mentioned here. Oh, no, it's not mentioned here. Just check if two arrays are permutation. So we have an assumption to apply the second approach, like should have no duplicates. No duplicates. Create a hash table for all the elements of the first array, traverse the other array from the beginning to the end, and search for each element in a hash table. If all the elements are found in hash table, return true, otherwise return false. Hash table insert and find take constant time, so the total time complexity of the algorithm is this, and that's it. Here is the check permutation. The next topic is about remove duplicates in an integer array, and we'll take a break here.